Today is October 19th. The homework for tonight is 3-7 out of Big Ideas, page 160, 1 through 41 odd, 47 and 48. All right. So the first type of problem that you're going to see in tonight's homework, it's going to ask you to graph the function and then compare the graph to the graph of the f of x equals the absolute value of x. Now, before we even do that, let's look at that. That's what we call our parent function. Let's look at what that looks like on a coordinate plane. So if I'm creating myself a coordinate plane, and I've got the function, what did they give us? The f of x. It was the f of x equals x, the absolute value of x. So how do we go about graphing this? How do we go about graphing it? You can tell me what to do here. Luca?
You start from the origin and you just keep going up.
No, we don't just start. I want to know how we would go about graphing this. Yes?
So first you would put it into two problems, which would be f of x equals x and f of x equals negative x.
No. We can just do, how do I graph a function? Any function, most basic form of graphing is?
Substitute the x for
Right, make a table. Okay? I'm going to make it horizontal because this book likes to use the horizontal. Okay. And instead of y, what are we calling it? The f of x. So you should be graphing along with me. This is supposed to be f of x. Okay. So we're going to choose. We choose our x's. So what x are we going to start with? Preston?
-2.
Good. -2. So when x is -2, I'm actually going to switch to red now. -2. What is my y going to be? Ryan? 2. Okay. And I'm going to plot that point. -2, 1, 2. Okay. When x is, let's choose -1. Some negatives, some positives. What's my y going to be, please? Maya?
1.
1. When x is, and I'm going to plot it, -1. Oops, what am I doing wrong here? Just for the recording. Okay, so it's -2, +2. And then I have -1, +1. What's the next one going to be, Sierra?
0, 0.
Good, let's try a 0. We get to the origin. Jack? Now what?
Oh, you have positive 1,
And
1.
1. Good. And Ethan?
Have +2 and 2.
Good. And this is what it looks like. Now, you will notice that when we have the parent function, is just the absolute value of x, it will always be what shape? It will be a V. And if there's nothing else done to it, the vertex starts at the origin. What do you think a vertex is? Ryan? It's a point in a shape. And in this case, our point, this is our minimum or our maximum. So when we have absolute value, the minimum is at the bottom of the V, and the maximum would be at the top of the V. In this case, we don't have a maximum, we only have a minimum. Okay? I want you to notice something about the V. My minimum is at the origin, at 0. And my maximum, we don't have that, but it's opening upward. That's why we don't have one, because it never stops. It goes on and on forever. Who can state the domain here? Who can state the domain? Irene.
All real numbers?
All real numbers. When we have that slanted line, it's going to be all real numbers, because even if I pick an x right here, what is that x? What is that x? 1, 2, 3, 4, 5, 6. comma 0. Or if I pick this x all the way out here, negative 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6, 7. Negative 7, I'm going to go up. Be right up about here, right? So I'm going to eventually hit all of the x's. Does that make sense? That's why it's all real numbers. Okay, so my domain is all real numbers. What would my range be, Shaylin?
Y is greater than 0.
Greater than or equal to 0. Okay, so these are the characteristics of our parent function. I'm now going to go back. Now, knowing that, whoops, let me come back right here. I want you to notice, what is the slope of this? Going in this direction, what is the slope? Ethan. What's Ethan? Liz.
1.
It's a 1. And going in this direction? It's negative 1. It's just negative 1. So you will notice the slope is 1 on any parent function, 1 or negative 1. Now, when you do the parent function in the future, you don't need to do the table. I will trust that you can start at, because I want you to compare everything you do to the parent function. You can just draw it out on your graph. Got it? Yes or no? You don't need to do the table. You can start at the origin and do a slope of 1 and negative 1 and get yourself the parent function down. Now, we are comparing the f of x to we're comparing the g of x to our parent function, the f of x. Okay? So the first thing I want you to do is make a table. Yes?
For the f of x equals the absolute value of x, wouldn't y also be all real numbers? Y.
No, because we're going to look at it again. Okay? Because you're never using any y values less than 0. Your y's, it starts at the origin, and only the y values will be used further up. Okay, so step 1, we're making a table. Okay, some negatives, some positives. I choose my x's. Now they're choosing these. When x is negative 2, the only thing you got to make sure of is that you're doing your order of operations correctly. Now, although my PowerPoint chose my x's, you're going to have to choose your own x's. Is that clear? And make your table. So when I substitute that negative 2 in there, negative 2 plus 3, the absolute value, what is the absolute value of negative 2? 2 plus 3 is what? 5, that's right. Okay, so when x is negative 2, my y is 5. When x is negative 1, what is my y? What is my y? Yes, Ryan. When x is negative 1, my y is going to be 4. When x is 0, what is my y? When x is 0, Ethan, it's going to be that positive 3. I put the 0 in. Okay, when x is 1, what is it going to be? Zenzele? 1. Good. When x is 2, what is it going to be, please? Chloe? 5. Now you will notice this sort of symmetry here. Sometimes you see it and sometimes you don't, depending on the x's you pick. But with an absolute value, you're always going to have that. Whether you see it or not, it exists. Okay? Now, before we were learning, so we are going to always plot our parent function. Oh, I put the wrong one in. I'm always going to plot the parent function. Okay? That's not working either. Oh, I know why it's not working. Okay, I'm in drawing mode. Sorry, guys. Okay, we're always going to plot the parent function, which is the black line, and then we're going to plot all these points. Sorry. There we go. Okay, we're plotting the parent function, and then we plot all of our points. We plot the parent function. You don't need to make a table for that. We're only making a table for our transforming function. So, the absolute value of x plus 3. I draw my lines through it, and it looks like this. Now, look at the graph. What happened? What was the transformation? Luca.
We raised everything 3.
We call that shifting.
We shifted it up 3 units.
Which direction? We call that up instead of up. We call it, Amrit? Vertically. We're shifting it up vertically 3 units. Now, where do we see that in the equation? Where do we see that in the equation? Annabella.
The plus 3.
Remember last week, when it's outside the parenthesis or the absolute value, it's the plus 3. Questions there? Okay. Now, can you state for me the domain of the original function? The domain, the horizontal spread of all the possible x's. Let's go with Annabella.
All real numbers.
All real numbers. And the range of the original function? Ethan Remes. Okay.
Y is greater than or equal to 0.
Y is greater than or equal to 0 because it doesn't go, only the values of y above the 0. Now, in the transformation, let's compare the domain and range. What is the domain, Ethan, same Ethan, for this transformation, the g of x?
It is
Domain.
domain.
Yep. Domain is my x, my input values.
Still all real numbers.
Still all real numbers. What about my range, Ethan? Same Ethan.
The y is greater than or equal to 3.
3. Do you see? So here, my domain stayed the same, but my range changed when I have a vertical translation. These are the kinds of things that a Common Core test is going to ask you to analyze. Okay? If they want you to look at a function and then look at it, you're going to look at your domain and your range. And you're also going to talk about, from the equation, what's happening. The original parent function, it's been shifted up 3 units, vertically 3 units. All right? Now, that's basically what all of this is talking about. Okay, so we're going to ask that question every time we graph one. Okay, last week we studied this. What happens when we have a number that's been added or subtracted inside the parentheses or inside the absolute value? Somebody I haven't heard from. Callie, what happened?
It's a horizontal.
It will be a horizontal shift. Let's see that. We're going to make our table. We're going to graph. I'm going to choose my x values. This time I'm choosing 0, 1, 2, 3, 4. Now they happen to know something that you don't know yet. Because I probably would have chosen some negatives, like -2. But we'll add those afterwards, okay? So as I go to plot the points, I'm going to always do my first one, right? Now, the one thing I'm asking is, and then I'm going to plot all these new ones, had I chosen that -1, what would my new y be? Preston?
3.
Okay, it's going to be -3, which is 3. If I choose -2, Luca?
4.
It's going to be 4. Okay? Because of the absolute value. Now, I think the reason why they didn't choose these, they want you to see the symmetry here. And if we had chosen those negatives and only gone up to positive 2, only gone to here, we wouldn't have seen any symmetry. Right? So that's why they chose those. So you've got to be careful and you've got to keep your eyes open that whatever numbers I choose, it should be symmetrical around the vertex. It should, every time I see absolute value, it should be what kind of a shape? A V. Notice, my x is positive 1, but my y is positive 1 here and positive 1 here. Does that make sense? There's always a symmetry with these absolute values. So I draw the line. I then draw the line. Now, we're going to ask the 3 things. What happened to the graph? How did it transform? What are we going to see? Say, how did it transform? Zenzele.
It moved horizontally
2 units, which direction?
to the right.
To the right. It moved horizontally 2 units to the right. Where can we see that in the equation? Ryan?
Inside the absolute value.
Inside the absolute value. Remember, when it says minus 2, it really means we're moving positive 2. Are we remembering that? Now, tell me about the domain. Domain. The domain, Luca?
It's still all real numbers.
All real numbers. The range?
Oh, y is for the original? Y,
No, for the new.
Oh, y is greater than or equal to 2? No?
Nope, not for the range. The range is what? My y values, right?
Oh,
What is it? Try again.
y is greater than,
Greater than or equal to
not sure.
my y values that are being used. Okay, here's a y, here's a y. You know, here's 1. What are all the numbers here? Do I ever go down here?
No.
So y is greater than or equal to what? Ethan?
0.
0. 0 on the y-axis. I never use any y less than 0. Okay? Now, compared to the original one, that's the big key here. If you're doing a Common Core, they want to know what happened in this graph and how does it compare to the parent function. Did the domain change? Did it?
No.
Did the range change?
Yes. Oh, no.
Y is greater than 0, y is greater than 0. Did it change? No. The domain and range stay the same. The only difference is the equation is translated 2 units to the right horizontally. That's the only transformation. Okay? Questions? Okay. So when it's inside, the only effect it has is it's going to translate it horizontally to the right or to the left. In this case, we translated it 2 units to the right. But my domain and range stayed the same. Okay, let's try another. Now, I have it outside of the absolute value. Okay? What do you think is going to happen with that? We did this a little bit last time. How does that affect it? Hershey.
A vertical shift.
It's outside would be here all alone, not being multiplied by it. It's not a vertical shift up or down. That would be a number all alone to the right. Or
I don't know what would be. I think it was
a stretch or a shrink. Okay? This is going to be a stretch or a shrink. It's going to make it skinnier or fatter. Skinnier or fatter. Now, let's see what happens with the whole number. What does the sign do? Positive or negative? positive or negative, what does it do? Jack.
It would decide whether it's going this way or this way.
Yeah, it reflects it. So if I multiply a negative towards all the inputs, all the x's, where's it going to reflect? Yes. Reflect over what? If I multiply a negative to all the inputs, which way does it reflect? Luca? Over the y. If I multiply a negative towards all the outputs, the y's, the entire thing, it reflects over the x. But the number itself tells whether it's wide or skinny. Okay? That goes for parabolas too, same thing. All right, so now we're going to make our table. We know what the parent function looks like. When x is negative 2, my y is 4. When it's negative 1, it's 2. It's 0, it's 1. And we're seeing that symmetry. And I'm going to plot these points. Okay? Here's the parent function, and these are the new ones. 0, 0. And I draw my line. Now, when I multiplied by a whole number, does it make it skinnier or wider? Yes. The blue is the new function. The black is the parent function. It's making it narrower because it's stretching toward the y-axis. It's stretching to the y-axis with a whole number. The whole number makes it skinny. What do you think is going to happen with less than, actually it's not, less than a whole number. I shouldn't say less than a whole number. Less than 1. What's going to happen, Luca? Come wider, okay? Okay, domain and range. So in this one, we say the transformation made it narrower, closer to the y-axis. Stretched it closer to the y-axis. Okay? What about my domain? Everybody, same or different? Same. What about my range? Same. Good. All real numbers for the domain. For the range, y is greater than or equal to 0. Okay? And really, I'm multiplying the whole thing. This is multiplying the 2 by the y. You know, we're really multiplying that whole thing, so it makes it the scale factor of 2. Can I move on? Okay. Now, what happens? We have made an educated guess that when we multiply by a fractional amount, it will be what, everybody? What shape? Wider or narrower? It will be wider, and yet, so we said it's going to get wider, but I see a negative here. So what's going to happen? I see the negative. Somebody I haven't heard from. How about right here? Is it Veronica? Okay, Veronica, what's going to happen with that negative? Not the negative. Negative and positive do one thing. Doesn't make it narrower or wider. Moreno? It's going to reflect. Now, am I multiplying the input by a negative or the whole output by the negative? The outside is the whole thing, the output. Inside is just the x values. So if I'm multiplying the whole thing, the output, where is it reflecting? Luca? I'm multiplying the entire, all the y's by a negative. Where is it going to reflect? Not over the y-axis. When you multiply all the outputs, the y's, it reflects over the x-axis. It's opposite. Okay? So, when you have a negative out here, we said it's going to be wider. Here's the parent function. Okay, because it's by a negative, it's reflecting over the x-axis and it's getting wider. Does that make sense? Okay, you can always make your table. Table method. When you don't remember this stuff, table method it. Make your table. When x is -2, I personally would have picked multiples of 2. Why? Why would I pick multiples of 2, Irene?
So you have a whole number and it's easier to find.
Right. I would have picked -4, -2, 0, 2, because I don't want to get those halves. So when in doubt, table it out. Okay? So I'm going to graph the parent function, and then I'm plotting these points. If you make the table, there's no arguing it. Plot the points. Then draw the line. Now, what did we say was going to happen, Veronica, because of the negative? Because I'm multiplying the whole thing, right? Really, look, I'm multiplying the whole thing. Guys, I'm multiplying the whole thing. So here, I'm not just multiplying when I've input a -2 here, right? I first take my absolute value. That becomes a +2. You with me? Once I take the positive version of it, a 2. And then I have to multiply it by -1/2. See how that negative is multiplying the whole thing? This and this, I should say. That is your output. So now I'm going to end up, I'm multiplying it by the negative last. So when I'm multiplying the entire thing, the output, I end up with it flipping over the x-axis. Tell me about my domain. Is it the same or different? Everybody. But my range is? Different. Who can tell me what the new range is? Hershey.
Y is less than or equal to 0.
Less than or equal to 0, and in the parent function, it's greater than or equal to 0. Yes. Okay, now we are learning about vertex form. I'm going to pause it and give you another video. I'm going to pause it, give you another video, actually make another video and upload it twice, okay? So please see the next video.